All right, so we are going to be taking a look at percent composition. So percent composition, we have a formula on the back of our reference table, mass of part over mass of whole times 100. So we will use this formula two ways. One, we could use it with a formula. So if we had something like, let's say, copper sulfate, and we wanted to know the percentage of sulfur in copper sulfate, we would do the mass of the sulfur over the mass of the entire compound times 100. Or the second way we will use this formula is with lab data. So let's say we did a lab where we had a mixture of sand, salt, and iron, and we wanted to know what percentage of the mixture was iron. We would take the mass of the iron over the mass of the entire mixture times 100. All right, so if we are doing a percent composition of a molecular formula, what we'll do is first thing we have to calculate the gram formula mass of our compound. So we have hydrogen, two hydrogens, each hydrogen has a mass of 1. Sulfur, we have 1 sulfur in the compound. Sulfur has a mass of 32.1. And we have 4 oxygens. Each oxygen has a mass of 16. That would give us 64. And total would be 98.1 for my gram formula mass. So the mass of 1 mole would be 98.1 grams. Okay, now what I need to do is find the percent mass of each element. So normally it tells us just to find the percent mass of one element, but this problem wants us to find it of each one. So if I'm trying to find the percent of hydrogen, I would take the total mass of hydrogen, which would be 2, over the total mass of the entire compound, and then times 100. We won't have to worry about significant figures on this problem because we were not given any data to work with. So we get a free pass on significant figures here. All right, and that works out to be 2.0%. All right, we can do the same thing to find the percentage of sulfur. So we would take the mass of sulfur, 32.1, over the mass of the whole compound, which is 98.1 times 100, and put that into our calculator. And that gives us 32.7%. And then lastly, we have to find the percentage of oxygen. So we take the mass of all 4 oxygens divided by the mass of the whole compound times 100. Kind of running out of space on this one. And that would give us 65.2%. So again, normally we would just be asked for one element, but this one wanted us to find it for all 3 of the elements. So now we have 2 more examples. First example, we are looking for the percentage of oxygen in carbon dioxide. So first thing we do is we got to figure out the gram formula mass of carbon dioxide. So carbon has a mass of 12. Oxygen, we got 2 of those. Each one has a mass of 16. So that would give us 32 for a grand total of 44 as the gram formula mass. If we are trying to solve for the percentage of oxygen, we would do the mass of our 2 oxygens, 32, over the mass of the whole thing, and then times 100. So we have 32 divided by 44 times 100, and that will give us 72.7%. Okay, our next one, how many grams of sodium are in 25 grams of NaCl? All right, there's a couple of different ways to do this problem. One way, you could do a multi-step mole problem with a couple of parentheses. Or another way you could do this is you could figure out the percent of sodium by mass in NaCl. And then once you do that, you could just take 25 grams times that corresponding percentage that you found in the previous part. Either way will work. This is probably easier than the mole way, but you could do the mole way if you wanted to. So we got to figure out the mass of sodium chloride. So sodium has a mass of 23 and chlorine is 35.5, which would give us a total of 58.5 for the gram formula mass. Okay, then we got to do percent of Na in there. So that would be 23 over 58.5 times 100. And that would give us, and that will give us about 39%. It would be 39.3%. Okay, now what we would do is we would take our original mass of the sample, 25 grams, times that percentage that we just found, because 39% of our sample is sodium. So it's just 39% of the 25. And that gives us 9.8 grams for our answer. Actually 9.83 grams. We need 3 significant figures.